In the next example, the choice of dv also will be very clear, and this is really ultimately will lead you to how to choose dv. Okay, so let's see. We need to evaluate the following function: the integral of t squared e to the t dt. So I'm starting by structuring. Let's choose u and dv, and therefore du and v will follow through. Okay, going back to the list of common integrals, we are looking to find a dv that is listed here on the left in one of the list of common integrals. So this is I don't know if I can show both at the same time. What do we have here that we have here? E to the x. We have e to the x dx. I mean, we love e to the x or e to the t because it's the derivative as well as the integral. So this will be our choice. So we start in this case, in most cases, that's where you want to start. You want to start with dv. So dv will be e to the t dt, and therefore v is e to the t. Now, this leaves us t squared to be u, and when you take the derivative, du dt is 2t, and du will be 2t dt. Unfortunately, we could not eliminate the variable, so turn out that for this particular example, you'll see that we'll have to apply the integration by part twice to eliminate. And this is something that it's part of the technique, you know. If you have something, if your choice of u is x squared or t squared, you need to do it twice. If your choice of u will be t cubed or x cubed, you'll have to do it twice. You have to do it 3 times. So let's proceed here and see what we come up with. Okay, so based on that, now we're going to say that the integral of t squared e to the t dt is now the integral of u dv, and of course the result will be uv minus the integral of v du. Okay? Somebody said I cannot see you. Let's see. So, u times v will be t squared times e to the t. Right? Minus the integral of v. Well, v is e to the t. And then du is 2t dt. Let's reorganize it a little bit. T squared e to the t. Yank out the 2 outside the integration. Put the t in front of e to the t, like so. Write it like so. Okay? And let's say here we have, those of you who want to really be picky with the c, let's take the c1 here, because I have a point to make with the constant c. That's why I'm sticking it in. I mean, normally it won't be necessary when you do indefinite integral. Just stick a c at the end and you'll be fine. But I want to use this example to show you why it is enough just to stick a constant at the very end. All right, now I see that I have a problem right here. I have another product, or something that looks like a product, that I need to undo. So, turn out that we need to do another integration by parts. So we need a second integration by part. So again, we need to have a choice of u and v, and we already have the experience, a good experience with, I think it's good experience with dv being e to the t dt, because this will give us v right away. So v equals e to the t. Now it leaves t to be u, or u, it leaves u to equal t, and du therefore is dt. And we can see now the conclusion of this exercise. So remember, all I'm calculating right now is this integral. So this integral, the integral of t e to the t dt, becomes the new integral of u dv, still going to equal to uv minus the integral of v du, except we have new u and v and so forth. So let's see, what's the new u times v? It will be t times e to the t minus the integral, the new v is e to the t, and du is dt. And now we can complete the exercise, and it will be t e to the t, well, complete this part of the exercise, minus e to the t plus c2. Okay, now, this will go right here. So going back to the original problem, I'm going to say the following. So the integral of t squared e to the t dt, we found that it's equal to t squared e to the t minus 2 times this result, right? So it's 2 times this result, so let's write it as t e to the t minus e to the t plus c2, and let's not forget the c1 from there, from the top. Now we need to clarify this mess. Okay, clear parentheses, see if we can simplify it a little bit. So we have t squared e to the t, and then we have minus 2 e to the, minus 2t e to the t, and then we have plus 2 e to the t, and then we have minus 2 c2 plus c1. To completely solve this problem, I'm going to do 2 things. I'm going to first factor out e to the t so that I have t squared minus 2t plus 2, all of it multiplied by the factor e to the t, and then collect the c's and say this is equal plus c, where c equals negative or equals c1 minus 2c2. Like so. Because they're all constant. Eventually, we don't care what is the value of the constant at this point. When we'll do a definite integral, or if we have additional information, for instance, what is the value of the integral at t equals 0, then we can find out the value of c. Now, the last thing we need to do here, when I see something like that, I want to check to see if I can enjoy the fruit of my labor. If this is not a sour result. In other words, we need to check to see if we take the derivative of this result, we get back t squared e to the t, right? So I want to check, and this is a little bit of Calc 1 here, and we're going to check by taking the derivative d dt of this result. So d dt of t squared minus 2t plus 2 times e to the t plus c, like so. And let's see, we have a product rule here. So the product of t squared minus 2t plus 2 will be 2t minus 2 times e to the t. And then, since the derivative of e to the t is e to the t, then we have plus the same thing we had to start with. T squared minus 2t plus 2 times e to the t, and then derivative of c, 0, and all I need to do is collect like terms. Okay, all the factors of e to the t. So we have e to the t times 2t minus 2 plus t squared plus 2t and minus 2t plus 2 times e to the t plus 0. Okay, now notice 2t minus 2t and negative 2 plus 2, and the end result is t squared e to the t. So yeah, this is correct. Yeah, yes, we got it right. Good for us.